coming up next, we've got a really great panel. And the next one of the pillars that we kind of wanted to chat about today, that we feel will set you up for DevOps success, is observability. And so observability kind of differs from traditional monitoring. And we've put so much time and effort when it comes to ops into monitoring. But as applications grow, as environments change, we need to think about different ways to keep an eye on what is going to potentially happen in our infrastructure. And so I've got three great people to be part of this. It's Alex Hidalgo, who is director of SRE over at Nobi9. We've got Quintessence Anx, who's a developer advocate with PagerDuty. Well, I know I'm too familiar with PagerDuty.
Everybody is.
Yes, and we're going to bring back April. April, who is a part of our Microsoft infrastructure and DevOps team, where we talk a lot about these concepts. And so I wanted to first start out and give everybody just a chance to briefly introduce themselves, at least Alex and Quintessence. Alex, why don't you give me the quick executive summary?
Yeah. Hi, everyone. My name is Alex Hidalgo. I'm the Director of Site Reliability Engineering at Noble9 and author of the SLO book. I've been a site reliability engineer for 12 years now, I believe. And it's really kind of, a profession that really lines up with my personality. And over that time, my primary interests have really always been incident command and observability. So I'm very happy to be here today.
Awesome. Thank you so much, Alex. And I really do appreciate you being here. And Quintessence is next. Hi, Quintessence. Thank you so much for being part of this. Why don't you give me that executive summary as well?
Executive summary. So I am currently a developer advocate at PagerDuty. I got here by way of a very circuitous path in tech that included tech support in a hardware lab, database administration, cloud engineering, infrastructure engineering, and whatever, as I just kind of meandered my way for about a decade throughout, located near Niagara Falls. So if y'all ever want to take a nice trip out and see something really cool, we do have an amazing waterfall. You might have heard of it.
And I know you've been involved in the DevOps Days community, taking part in DevOps Days Buffalo, being part of that team of people that really bring that event together and serving that Western New York area. And now, because of virtual conferences, the world.
Well, we did last week at a drive-in.
Wow.
We figured that it started as a joke, but then it was like in our January meeting to plan for October, vaccines weren't out, right? And we're like, how do we commit to a venue without committing to a venue was the problem to solve. And then it was like, if there's a vaccine or masking or loose requirements or strict requirements, we can have people in their car, out of their car, whatever. And we're like, actually, this might be a joke. Like we might actually do an in-person conference at a drive-in that'll allow us to have as much flexibility around lockdown, non-lockdown procedures as an event venue possibly could. And it went super well. Also, seeing talks on a drive-in screen was really cool. Not gonna lie.
Awesome. I love it. And then April, I want to bring you back just for a second and just say welcome back to the show. I really appreciate you coming back here and being part of this panel. And I'm actually going to ask you this question first. And we'll get into taking questions also from our audience. If you'd like to use the chat windows that you've got in your different services. We want to hear what you might want to know, but we've got a couple questions ready to go. And so the first one I am going to ask, and I'll ask you first, April, is how do you differentiate observability from what is traditionally known as monitoring in IT systems?
So when we think of monitoring, and I spoke a bit about it as well, it's in that kind of final phase of deployment, right? We're monitoring around something. I feel like observability is the full end-to-end process. So it's not just the monitoring piece, but it's how do we track things throughout and have that visual ability throughout. So I spoke about it a little bit before when I talked about Azure boards. and the planning tool. Like we have full visibility within the organization, what we're doing. We have automation built in, so we know what's happening. And that might be hooking into Microsoft Teams or whatever chat tool, Slack, et cetera, we use in our organizations. And having that ability of what's going in the whole process, and not just the monitoring, that's the quote infrastructure and app movement, but also the whole process that's in the DevOps cycle. So that's everything end to end. And in my demo, for those of you that tuned in, we could track the pull request number to what we're doing. And you can take that even further by hooking in GitHub, into email notifications, into like a chat ops thing where you have it notify a Teams channel. So for me, that observability is in the full end-to-end process in DevOps, not just the monitoring wraparound.
Absolutely. And so, Alex, I know you've had probably one of the beginning introductions of SRE to the world at your time. I believe it was at Google, and really understanding how the process of observability fits in. And so I ask you, how do you kind of differentiate it from, say, the old style of, putting in Nagios or something like that to keep you abreast of what's going on?
Yeah, I mean, the first thing is that, one, I'm a nerd. And this means I really kind of love the original definitions of a lot of these things, right? The concept of observability existed way before microservices. It's part of control theory, which is, a way to think about complex systems. And, and we don't have to get super in depth there. But the point is, the original definition, I think, actually still really holds. And monitoring gives you things that you know to look for, known knowns or even known unknowns. But what really makes observability different is the concept of emergent behavior. Right? Emergent behavior, or emergence, is the idea that you cannot possibly understand the performance or the traits that will be exhibited by a complex system until the many components of that system are actually interacting. And so monitoring generally means that you have a developer writing the code, says, I'm going to export this metric. I'm going to send this time series out. I'm going to log this log line. I'm going to use this framework to ensure that these 500 metrics are all being emitted from my service. And that's awesome and important. I actually don't think observability replaces monitoring in any way whatsoever. You need all that data. But proper observability means having the systems in place, having the data available to you in order to explore and locate those emergent behaviors. The ones that your developers cannot think about ahead of time. The ones that your developers cannot say, oh, I'm going to add this log line. I'm going to add this metric. I'm going to export this to our system, right? These manners in which complex systems and the components of them interact with each other, you can never know what they are. And observability means being able to track what those potential issues are.
Great. And Quintessence, I'd love to get your take on this as well. I know that PagerDuty, it's a big part of that process, because you're letting people know when these events happen. And so I'm curious about how you differentiate observability from monitoring.
So it really goes back to a bit of what Alex said, where if you take a step back and say, what is observability? And he mentioned control theory briefly, and I'm also going to mention it briefly, but very specifically, we talk about the outputs of a system. So when we talk about observability, we talk about a highly complex system usually these days, right? And so you can't really know the state of the system linearly from a tiny little app. You need to actually know what it's outputting in order to know what state it's in. So that's observability. And if we look at what observability is typically supported at, I hate pillars. It's that whole allergic to buzzword thing, but we'll go with it. So, right, you have metrics, events, logs, and traces, right? And if we shift over to monitoring, what is monitoring? What do you fundamentally monitor? Normally, you're monitoring maybe metrics and also logs, right? So when you think about it like that, monitoring is kind of a subset of observability, in the sense that in order to have monitoring function, you have to have a system that's at least partially observable. But having only monitoring configured by itself does not mean that your system is observable, per the previous, which is, can you actually deduce the state your system's in from monitoring alone using only metrics and or logs? No, right? You haven't implemented enough. And so I feel like they're less like different than one is a superset of the other.
Awesome. I'm thankful. Like we I think have a good kind of groundwork for what we're going to continue to talk about by understanding kind of that difference. And there's been a term used so far, complex systems, and I really think about how complex systems fail. The paper by Dr. Richard Cook, and if you haven't read it, I really recommend it. That really made me think a lot more about the implementation of SRE in general, because I think that complexity begets failure. It's just a part of how things work in this world. And so because you brought up that term first, Alex, I'm going to ask you, what points of data do you believe have the most relevance in regards to understanding a complex system?
I mean, that's a difficult question. And I think it's because complex systems are almost by definition unique. I don't think there necessarily is a list you can check off of saying, oh, I have a complex system here, therefore I need to be watching A, B, C, D, because every situation is going to be different. How these complex systems are composed, what their components look like, how those behave, how they've been introduced, what order they've been introduced in, are all going to really kind of change what is most important, perhaps, to be looking at for any system, like in and of itself. That said, I do think that you can kind of identify a subset of things that you need to be looking out for, because generally speaking, complex systems exist in order to they have a goal in mind, right? We design them in order to execute a task. We as humans design them to do something for us. And knowing what that output is supposed to be, right? This kind of goes to what Quintessence was saying, right? Like the original definitions involve what can you infer about the internals of a system by its outputs. The best starting place you can have, even though you can't have a perfect roadmap, you can't say, oh, I need this. The closest you can get, I think, is to say, okay, the system was designed to do X, and therefore the output should hopefully look like Y. And that's a great place to start.
Great. So I'll defer next to April. What do you believe are some important data points in a complex system?
I think they're called complex systems for a reason. And in my career, when I worked with engineering prior to joining advocacy, a lot of my role was breaking down complex systems. So, just like Alex said, what is it supposed to output? What is it trying to do? And how do we get there? And in a lot of the times, it's breaking that system down. And that's been a hard task. And it depends if you're looking to transform it or what you're trying to do with it. Why are you breaking it down? Why do you need to figure out what it's doing? And is it doing what's supposed to? A lot of the complex systems that most people out there have is because we've built something and it's grown organically over time, and we didn't think about how we're going to scale something. So I think it is such a hard thing to measure, and each complex system that I've worked with has always been different, and we've had to have different points in which to measure it from and how it works, and we have to break it down. So for us in the engineering side, when I was in the engineering side of Microsoft, we really had to break those down and find those, and each system was different. It could be very code heavy, it could be very infrastructure heavy. Each was so different, and a lot of times they didn't have quote monitoring around it. We didn't have observability around it. We knew X didn't produce Y, or didn't do Y as it was supposed to, and it kind of limped along. So we need to figure out why.
Gotcha. And so Quintessence, I'll ask you the same thing. What data points do you think are important to kind of track in a complex system?
So it does kind of go back to systems aren't complex, so you're not going to be able to have a checklist of data points. However, complex systems are not unique to IT. It's something that we borrowed, mathematically speaking, from gestures vaguely, right? When you're in certain levels of mathematics, you do a lot of modeling around species and populations for complex systems and whatever. And all of this is to tie into the fact that there is kind of a definition for qualifying criteria for what a complex system is. And you have numerosity, disorder, diversity, feedback, and non-equilibrium. And when you're thinking, what data points do I need? If you understand those 4 to 5, depending on how you separate them out, points, you can start to say, what data am I outputting that tells me these different criteria, so I can see how complex my system is. So numerosity is how many things do I have? microservices, dependencies, whatever you define thing as. And then you have diversity. How many different things do I have? Do I have a dozen microservices and 5 libraries, whatever? And as you go down the list, what is equilibrium and non-equilibrium state? And this goes into like, monitoring percentiles and exceeds the scope of the question a little bit. But when you start to think, okay, I understand what a complex system is, and you start funneling data back up in, now you can start asking questions to tell you what type of data you should be focusing on. So less prescriptive than please check your, inbound traffic. But it does tell you if you do need to check for that, like where it falls under when you're trying to figure out your complexity. And you also need to, you also need to check randomness, and that is how chaotic is your system. That chaos experiments is great for that, but.
And you just led into my next question.
You're welcome.
So you mentioned chaos, and chaos engineering has become a really big, another buzzword, if you will. And it's actually become a great way of finding problems and using observability before the problems actually impact production. And so I'll ask you, Quintessence, how do you feel that testing in production fits into this whole kind of observability as opposed to just standard monitoring?
I'll say what everyone else probably also says. You're always testing in production, whether you mean to be or not. I feel like I have to say it. Someone else will. So I beat you both to it. Sorry. Intentional testing in production. Mostly you need to make sure you're doing a lot of pre-work, because even when you talk about like chaos experiments or things that can be done to kind of give you more reactive outputs to check for than you thought to, the whole known unknown problem, where you start to know what to track, but then you need something to tell you what else you're not tracking. You don't want to just start running chaos experiments in production without running them in dev or staging first. So a lot of the testing in production, when you're doing it intentionally, kind of goes through this planned phasing of, even though they're smaller but hopefully mirrored versions of production, you roughly know the radius of impact of everything. And that is to say, you don't want to be in a situation where you think you're testing something that's confined to US East. We're just going to use AWS. Why not? US East. And then all of a sudden it's creeping up in APJ over here. You're just like, I didn't think these were talking to each other. And now I can't shut it down. I can't shut down the experiment because
Awesome.
I didn't plan it out. Yeah.
So, April, how do you think testing in production fits into the observability story?
Well, I think Quintessence summed it up well. You're always testing production. And I think this is where it's important to have like for like systems. We've seen a lot of customers that are like, oh yeah, we found this thing in production, but dev test or staging looked completely different than the production environment. And I'm like, well, you're not testing in production. You're actually testing on something live that your end users are seeing. So you really have to think about how are you testing it? You want to test in these small, you want to either use feature flags or use different environments that are like for like, and how you can replicate that. And I think we see a lot of people that don't have that set up and will test and are actually then just scared to do things in production. And that is difficult because they're not getting that feedback mechanism. But those that are willing to test in quote production or something that's like for like, they're getting that feedback earlier and they're having that identical system. And I think that's really key to getting that feedback and addressing it, because I think also when we talk about these big complex systems, if we're then doing these things, 3 months past or 6 months past, we don't know how to fix them. So this has to be done incrementally if we are doing that in a direct production environment.
Great. And Alex, I'll give you a chance to kind of give your thoughts on testing in production as well.
Yeah, so I think it fits into the observability story because they both kind of have the same aim, right? They almost have the same goal, right? An observable system, you build more observability into your systems, again, to go back to identifying emergent behaviors, things that you hadn't thought of ahead of time, things that you hadn't already planned for. And that's what testing in production, that's what chaos engineering, that's what experimentation gets you as well. It exposes new ways that your components may interact and new failure modes for those components and your complex system overall. And, if you don't have observability, you may not even be able to notice those things. Something may break and you have no clue why. So you're running experiment X and thing Y happens. If you don't have proper observability, you learn nothing from it, right? You do know that X causes Y, but you don't know why X causes Y.
Absolutely, absolutely, very, very cool. And so, we've covered a couple things, and I will ask you, Alex, to kind of bounce off that. And someone wanted to know, does chaos engineering is it even considered a part of observability? Are they related? And I personally think they are. I think that reducing failure or improving reliability of complex systems is kind of one in hand with the other.
Yeah, I mean, I think they relate in the way I just kind of mentioned, right? Like you need proper observability, otherwise your chaos engineering work is not going to be very useful, or at least not as useful as it possibly could be. I don't necessarily consider chaos engineering or continuous verification is a recent term to encompass as part of this that I really like. I don't know if it's necessarily part of observability, but you can't do one well without the other.
Sure, absolutely. Well, I've got about, I guess, maybe one or two questions left, and I'm going to ask a lightning round here around tooling. So, Quintessence, what type of tools can help best identify problems before they impact end users?
So it's less about very specific tools like use this vendor, et cetera, and more about, again, understanding what you're trying to gather. So when we go back to like metrics, events, logging, and tracing, choose a tool that does one or more of these things well. And by well, understand what you're outputting and know how unique you are and how normal you are to everybody else, so that you can say, okay, am I an edge case? And does this vendor like meet that need? Or do I very specifically need to use this specific person because we're doing something wonky for whatever reason? Wonky, highly technical term, right? So when you're looking at tools, make sure that you're supporting all of those. And the reason it's good to balance tool explosion with what you're putting into the tool is because you don't want to do the tab thing where you're like data crawling through your system and you have like 5 tabs open and you're like, this correlates to this and this correlates to this. So having it reasonably consolidated and accessible to the whole team. And by that, I mean, don't just make it so infra can see infra things and front end can see front end things, because they'll need to talk to each other, right? So everybody kind of needs access to the same level of data for the most part, unless there's like a secure reason to not do that. That's good. Really why I go with it.
So Alex, I'll ask you, I know that, as a person involved in SRE, you implementing this type of tooling to actually keep an eye on the observability and health of your applications is big. What do you think is an important tool that people can implement?
Math. Just simply understanding that there are models that have been created decades, sometimes centuries ago, to better understand what data you're actually collecting. It's very easy to extract a bunch of telemetry from your systems. Well, not always easy. Sometimes that is difficult, but but then you have all these numbers and you have all this data and you have all this telemetry, and then what do you do with it? And just having a basic understanding of basic statistics, regressions, correlation analysis, even something a little higher level like using service level objectives, right? Something that kind of provides you a summary overview of things as opposed to just having, tens of thousands of time series, like that you don't know what to do with. I've learned more math post college than I ever did in college, at this point. And, I'm certainly not an expert because I use programming languages to actually do the math for me. But I think it's very important to at least understand what kind of models exist, what kind of formulae you have available to you to better understand what's actually going on.
Great. April, what tools do you think can best help people out?
And again, I think the specific tooling there's so many out there, and you have to find the tool that's best fit for what you're trying to do. And I think my biggest piece of advice to organizations and people out there, use the same tooling across the different groups in your org. I've worked with different organizations that use like 16 different tools. I'm like, which one should we use? Or how do you do it in this tool? And I'm like, why are you using 16 different tools? I'm like, we let each group pick their tooling. So there's no continuity. So the data they're collecting is just data, and it's not going anywhere. And I think it's really important to look at the data, know how to, what you're looking at, so you have a baseline. So whatever it is you're trying to improve upon, you need a baseline bit of data, you know how to improve it. and where it's going. That gives you a starting point. But I think getting in similar working tools across your different teams is really critical, and then doing something with that data. And there are so many tools out there. And again, Quintessence said it, you have to kind of make a list of what does your organization need? What do they need to get out of it? What kind of things are they looking at? And you have to find the tool that's best fit for the organization. But you have to use it and use it properly.
Great. So we've only got about 4 minutes left or so, and so I wanted to ask each of you in just succinctly as what you would give as far as advice to somebody who's implementing observability. And April, I'll let you kind of kick that one off.
No pressure. My advice is find the right tool that's right for you and your teams. Implement it early. Start gathering metrics. Use that data. And again, we say it in DevOps: fail fast. Start using it. Find what works. Find what doesn't, and move forward.
Great. Quintessence, would you like to kind of give your take on this?
I'm going to echo what Alex actually said about using math. The idea, a really easy example, low-hanging fruit, is percentiles, right? Know what the numbers mean. So if you say, I'm using averages, that means you're in your good state 50% of the time. If your SLO is 99%, it doesn't help you. So knowing the math for why you're making the decisions to watch what you're watching and gather what you're gathering will really help you, both in terms of what things you're going to be outputting from your system, and thus drive what decisions you make about what it's getting put into.
Absolutely. Alex, so last, I'll ask you to kind of give us that same quick answer.
Yeah, I mean, I have a lot of opinions here because I've been on pretty observability-focused teams for the last 6 or 7 years of my career, 8 maybe even. So I want to answer from a business perspective. These systems are expensive and are likely going to be your busiest if you're not using a vendor, right? If you're building something in-house, because everything else you run has to talk to those systems and has to send them data. So I don't care how huge and important your primary web app is, the observability tools behind it, your logging systems, your metric systems, your tracing systems, like your production event change logging systems, whatever they may be, they're going to be busier. They're going to be more difficult to maintain than your primary, profit driving, web application. So
Gotcha.
Give them the right resources in both money and humans.
Well, thank you, Mr. SLO. I do really appreciate that answer. I think we've had a great time having this conversation. I'm going to start getting ready to say goodbye to 2 of our speakers. One of them is going to stick around. But Alex, where can people get in touch with you on the internet?
Find me on Twitter. I use it too much probably, but you can find me at Hidalgo SRE, and go check out what we're doing at Noble 9 at nobl9.com.
Very, very cool. And April, I know you've got the DevOps Lab and lots of other things going on. I know that that's coming back in a couple of weeks. Any other way people can reach you on the internet?
Yeah, everyone can follow the DevOps Lab on Twitter. We have a YouTube channel. Feel free to reach out to me via Twitter or LinkedIn. If you send me an email, it will go down a black hole.
Well, I guess you and Kat have a lot of things in common as far as your emails are concerned. And so I will say goodbye to April, goodbye to Alex. Thank you both so much for joining myself and Quintessence here. I think that I really enjoyed this conversation.